All right, I think we got 3 variables next. Oh, look at that. Who's cute you are. Again, directions, change them. So now this is a little more exciting. Actually, 50% more exciting because it's got 3 variables. So steps 1 and 2 work together. You want to pick a variable that's going to be easy to eliminate twice. But the rules are still the same. Pick one that has a coefficient of 1 or -1. Well, notice x, y, and z somewhere all have a coefficient of 1 or -1. So, which one you want to get rid of, x, y, or z? We can, any of those are good. I don't care. We can do z. That's fine. So step 1. Step 1. Pick 2 variables to eliminate z. Pick 2 equations to eliminate z. Which 2 equations do you want to pick? First 2. So notice we have 2z and a 2z, both positive, so we need to make one of them negative. So why don't we multiply the second equation by -1? Of course it does. So multiplying the second equation by -1, we'll get 3x plus 4y minus 2z equals 11. I don't know what it is, but I think this pen makes me write neater. It's got magic powers. Adding these equations together, what do we get? Good.
Can you say that first step might be?
Sure. So they had picked the first 2 equations to eliminate z. So notice both of the z's have +2 coefficients. So we need to make one of them a -2 coefficient. So we chose just to say multiply the second equation by -1. So now that we'll have a +2 and a -2. So step 2, we'll actually have a step 2 here. We have to pick a different pair of equations, but get rid of the same variable z. So I'm just going to tell you, pick the first and the third. And I want you to do this step on your own now. So you use the first and the third equations to get rid of z. And then we'll do the step together. So what would you multiply the third equation by? -2. And if you multiply the third equation by -2, what would you get? Minus 2z. Good. Questions on that? So if we add them together, how many x's do we have? -x. Y's. This is actually very nice. And constants? -8. -8? All right. Well, the problem is, notice at step 2, in both equations, step 1 and 2, we have 2 variables. We need to get down to 1. So what we do is we're going to take these 2 remaining equations and eliminate again. So this becomes now a little 2-by-2 system, 2 variable system of x's and y's. Well, this one turned out nice because notice we already have a +5y and a -5y. So what would we have to do to these equations to eliminate a variable? Just add them together. So that'll be step 3. (4x plus 5y equals 17) equals (x minus 5y) equals (8). Adding them together, we'll get 3x equals 9. Is that okay? There you go. Step 4, solve for the remaining variable. Dividing both sides by 3, we get x to be 3. Now step 5 has a little more work, unlike previous examples. What we're going to have to do with that 3 is we're going to have to go back up the ladder, meaning we first go to where we had 2 variables, namely at the end of steps 1 and 2, and then we go back to where we have 3 variables at the beginning of the problem. It does not matter which of these 2 results from step 1 and 2 we plug x equal to 3 into to solve for y. So which one would you want to pick? First one works for me. So in step 5, instead of 4x plus 5y equals 17, we'll have 4 times 3 plus 5y equals 17. What do we get for y? 1. Now that we have 2 of the variables solved for x and y, namely, we go back to any of the original ones as long as there's a z there, which they all have a z, and solve for z. Why don't we use the third one? So instead of x plus 3y plus z equals 7, we found x to be 3, we found y to be 1, and what does this say about z? Z equals, 1. When you have 2 variables, it's called an ordered pair. When you have 3 variables, it's called an ordered triple. What's our ordered triple here? 3, 1, 1. Whatever.
Let's go like X, Y, Z.
X, Y, Z, correct. So alphabetically. Actually, that's sort of not true, because when you have 4 variables, it's X, Y, Z, W. Yes, please.
Number 5.
Yes.
If I see the 12, y 17, y is 1.
Sure, so we get 12 plus 5y equals 17. So if you subtract 12 from both sides and divide by 5,